Welcome to Mathematics Department graduation ceremony. My name is Alexander Karachovsky and I have the privilege of serving as the chair of mathematics. Today is a very special time when we recognize our graduates. All of us know that getting to this point required an enormous amount of work, tremendous dedication, motivation, and ability to overcome many difficulties on your path. This year's pandemic presented a unique set of challenges. I am very proud of all of you for persevering despite the difficulties it brought. The past year hadn't been easy for anyone. I am very sorry that we can't get together to celebrate and honor a wonderful achievement. Luckily, the technology helps me to offer all of you my heartfelt congratulations. We are happy that you made this great choice to study mathematics. Math and logic skills you've acquired here will serve you well whether you choose a career in academia, in industry, or even in seemingly unrelated fields like medicine. Indeed, many mathematicians and statisticians continue to work around the clock to provide us with better understanding of the pandemics and to help people at all the level of government to make better decisions. We hope that you will spread the message about vital importance of mathematics wherever you go. This is also a moment to reflect on all the people who helped you along the way, parents and family members, classmates and teachers at school, and your CU professors and classmates. All people who rose to the occasion and helped you to do your best and to complete your studies under these difficult circumstances. In the years you have spent here, you became an integral part of our department, and you will always remain one. I would like to congratulate you again and wish you success in all your future endeavors. Stay safe, and I'm looking forward to a day when we can all meet in person to celebrate your wonderful achievement.
Congratulations to all of you receiving degrees, and congratulations and thanks to your support structures. You have chosen the best academic discipline at one of the finest universities in surely the most beautiful college area. I hope you remember your time here fondly. Thanks to Dr. Gorokovsky and the mathematics department for asking me to speak. With your degree in mathematics, you will have a great life, although you may not know the kinds of problems you will solve with people you don't yet know. You may have to learn the vocabulary of other disciplines to work with some people. You already know how to solve problems and cope with frustrations. I wish you happy, humorous, and smart companions. After so many years since my last class, making contact with the CU Mathematics Department has been enjoyable for me and forced me into a little deeper reflection on my life. I graduated over 60 years ago. A few months ago, I did have this revelation. I owe my professional life to Sputnik. Sputnik was the first human-made Earth-orbiting satellite. I had just started my second year at CU when Sputnik was launched on October 4th, 1957. It did not take very long for government and technical leaders to decide that the United States was behind Russia in science and technology. A plan was hatched and put into place. The Harvard Gazette said that Sputnik woke the nation up, serving as a focusing event that put a spotlight on a national problem. Midway through the spring semester, our math instructors announced in class, take a civil service exam and you might get a summer job in Boulder. I took the exam and I was offered a job at the National Bureau of Standards. NBS became NIST in the 80s. My position was student trainee in mathematics. There were trainees in other divisions and labs. This was a great model for training people for the work needed. The student could continue in school and work part-time. I was assigned to radio standards physics. However, when I started, the radio standards budget was out of personnel funds for the remainder of the fiscal year. I was assigned to another group until July 1st. I learned to process the long rolls of data from the rhombic antennas a short distance from Boulder. On July 1st, I moved to radio standards. Shortly after, I was handed a soft-covered pale blue and white book. My supervisor said, tomorrow you will learn to program a computer. Oh, great. What was a computer? What was a program? I took the book home and read without any real idea of what I was reading. The manual was for SOAP, Symbolic Optimum Assembly Program. At work the next morning, my coworker Bill sat down with me and a paper drum map. He explained commands to me, and we developed the instructions needed for solving our group's current problem. We placed the instructions and data on the drum to make the most efficient use of drum revolutions. In addition to learning to program that summer, I learned how to use the technical library. I also spent hours using Marchant and other noisy and large calculators to do what I would later program the IBM 650 and other computers to do. I continued learning new things at work, and some things were connected to classes at CU. That was a surprise to me. Pure math was useful in the real world. One humorous event at NBS was the arrival of Fortran for programming. All the programmers thought we would be without work soon. Our view was anyone could program on Fortran. But we kept our positions, and all of the PhD researchers just came up with more complex problems to solve on the computers. I appreciate having a degree in mathematics because of how and what I learned. I know you are going to appreciate having a math degree too. You may or may not go to graduate school, or you may change disciplines, but math is in you. No matter where you go or what you do, I hope you will become an ambassador for mathematics at any level you choose. If you are or will be a parent, remember your child's school can use your expertise. You can make positive statements about mathematics, or you can do enrichment work with students. When two of my children were in the local elementary school, some of the parents took the Great Books training program and led discussions with the 3rd and 4th graders. One day I woke up and said, lots of people do and will do great books, but no one does great maths. We talked to the principal about adding an enrichment program for the students. During math enrichment, we made Napier's bones out of popsicle sticks, formed Mobius bands from paper strips and a piece of Scotch tape. We drew on the single surface with crayons or pencils, cut bands in halves and thirds until the area was a nest of paper. Until Soma blocks were commercialized, I made dozens of them for gifts, from tiny cubic wooden beads to alphabet blocks. Place them on your desk or coffee table and amuse anyone who touches them. Where I live, members of Sigma Xi designed a puzzle contest for middle school students, hoping to interest more young people in science and mathematics. We had chili and wine when we graded the puzzles, and a good time was had by all. My examples are from my mid-years. There are newer examples of activities and games to share. Just borrow or buy one of the dozens of good and interesting books with fun ideas. So spread the word. It is great to major in math, to write a thesis or dissertation in math, to work with math, or to play with math. Some mathematicians prove theorems that have been waiting for a particular mathematician for years. Others are able to solve really deep problems. Some support other professionals in their work. There's many options for those graduating with degrees in math. I hope you will find your place or places.
So, first of all, let me introduce myself. I'm Sergei Kuznetsov, and I'm Associate Chair for Graduate Studies in the Department of Mathematics. And I would like to congratulate our students who defended their PhD this year. So this year, well, this is a tough year, but we have 7 students defended, and one of them actually will defend very soon, not yet, but still. So let me name them in alphabetic order. So that's how I have chosen the order in which I present them. Braden Ballantyne, he defended his thesis on well-posedness and global time behavior for LP mild solutions to the Navier-Stokes equation, and his advisor is Professor Chubak. Next, it is Ruo Fan Lee. He defended his thesis on primitive prime divisors, rings of integers, and class numbers in arithmetic dynamics. And his advisor is Professor Ich. Next, it is Shen Lu. He will defend soon. He didn't defend yet, but he will do this anytime. And he is defending his thesis on Morita equivalence of irrational non-commutative solenoids. Sorry. And his advisor is Professor Parker. Next, it is Matthew Pearson, and his thesis is on some applications of duality in cyclic homology, and his advisor is Professor Gorokhovsky. Next, it is Carlos Pinilla, and his thesis is devoted to Hodge decomposition for the Sobolev space HL on a space form of non-positive sectional curvature. And his advisor is Professor Chubak. Next, it is Albany Thompson. She defended her thesis on foundations of the steady Navier-Stokes equation on the hyperbolic space. And her advisor is also Professor Chubak. Professor Chubak had 3 students defended this year. This is a very, very rare, very special case. And finally, we have James Van Meter, and he defended his thesis on universality of SWAP for qubits, a representation theory approach. And his advisor is Professor Green. Okay, so on top of that, we also have students who defended their masters and either Master of Arts or Master of Science. Many of them actually continue their study for PhD degree, so I do not list them. But we have 2 students who defended their masters and do not continue. So first of all, it is Shia Yuwei. She did her thesis on sample covariance matrix estimations for sub-Gaussian random vectors, and her advisor is Professor O'Rourke. And then we have Trevor Manders. He didn't have any specific title for thesis, and his advisor is Professor Rodriguez. And finally, we have 2 students who did so-called concurrent degrees, so they got BA and a Master of Science at the same time. It is Yoshin Shen. His advisor was Professor Pflaum. And finally, it is Max Howard, and his advisor is Sergei Kuznetsov. Well, so what I'd like to add. So we are very proud of you, and we are really happy that many years ago you have chosen Boulder, our university and our department for graduate studies. We wish you all the best. We wish you luck. Like I said, we are proud of you, and we will miss you. Thank you.
everyone. I'm very proud to present my PhD graduate, Shen Liu, whose PhD thesis was entitled Morita Equivalence of Irrational Rotation Non-Commutative, or of Irrational Non-Commutative Solenoids, sorry. Shen received his BA from Lebanon Valley College in 2015 and his MA from UC Boulder in 2018. Congratulations due to Shen. It was a pleasure. It has been a pleasure having him here. So Shen studied some algebraic objects, but they were also topological in nature and that involved analysis. So sort of bridged the three areas of math. So here's a picture of the two torus, which can also be completely described by its continuous functions, which have two generators. Now, just changing this a bit, you could think of what we call C-star algebras generated again by two unitary generators, but this time the unitary generators do not commute. You have theta irrational number between 0 and 1, and you can take two unitaries, u theta and v theta, satisfying the relation below, obtain a certain universal C-star algebra from them. And this C-star algebra, A sub theta, is called the irrational rotation algebra, also known as a non-commutative torus. It's very important in the study of operator algebras to have examples, and this is one of the key examples of them. Now, moving on from this, it was very natural to study direct limits of these algebras. Just like when you study inverse limit of tori, you obtain solenoids. When you study direct limit of irrational rotation algebras, you obtain, or the non-commutative tori, you obtain what are called the non-commutative solenoids. And it was Frederick Lectre, Moliere, and I that first began their study, but Shen really took off and got some really nice insights into their structure. First of all, non-commutative solenoid is a direct limit of non-commutative tori, as described there. And there's a way of forming a C-star algebra from this direct limit procedure that has universal properties. And we get this non-commutative solenoid described by A sub alpha, calligraphic A sub alpha. A natural question to ask is, when are the two such objects star isomorphic? And when are two such objects strongly Morita equivalent? That is, when do they have the same representation theory? That's the more subtle question that's very difficult, and Frederick and I didn't know how to answer it. So Shen's concentrated on this in the commutative, in the irrational case, where the alpha or the theta you start with is irrational, in which case you can use K-theory and projections to really tell you a lot about the C-star algebra. So any projection in the non-commutative solenoid comes from a projection in one of its irrational rotation algebras, or one of its non-commutative tori that you use to make in the direct limit to construct the non-commutative solenoid. So if you take a projection, it has what we call a unique trace. And when you take the trace of a projection in K by K matrix algebras over the A alpha, it looks like C alpha 0 plus D 0. And Shen found a key condition was that the greatest common denominator of C0P D0 minus C0 X0 should be equal to 1, where P is the number we use, the prime number, to form the direct limit. And given that condition, Shen used it and was able to find necessary and sufficient conditions for two irrational, non-commutative solenoids corresponding to the prime P to be Morita equivalent. And I won't read out the theorem, it's listed there, but it was a really nice result, really fascinating, and be very excited to see where Shen goes next. He's interviewing right now for various teaching positions, and good luck with that. But we're so pleased he's here. I was so fortunate to have him as a student. Here is his little hood, my exercise band. Congratulations, Shen.
Thank you, Judy. Well, I definitely want to say thank you to my advisor, Dr. Judy Packer, for her support, guidance, wisdom, patience with me over the past few years. And I also want to say thank you to my family and friends for their love and support. Thanks again, Judy.
Thank you, Shen. And on to the next chapter, as you say.
Well, it's my great pleasure and honor to introduce PhD student of mine, Matthew Pearson. So his thesis is entitled Some Applications of Duality in Cyclic Homology. So on this slide, I think Matt tries to explain what this is about. So there is a helpful image which is supposed to, aid non-experts in understanding of the text above. And let me start by certifying that the caption is right and the image is entirely unrelated to anything in Matt's test, except for occasional use of the same letters. So as Matt says, his thesis is concerned with something called Fredholm module over an algebra A, and that's an abstraction of another notion which is called elliptic operator. Without going into too much details, let me just say that study of index theory of elliptic operators is one of the greatest achievements of mathematics of 20th century, and development of this theory further is a major topic of mathematics in our century. Okay, and I think Matt made an interesting and valuable contribution to this area. So the theory of characters of Fredholm modules, again, some rather relatively modern abstraction of classical index theory, and one of the simple but very nice application, which served as a source of interesting examples in my thesis, was application to actually a very classical topic, namely traces of difference of projections of projections in the Hilbert space. So Matt generalized all of this when instead of projections, one considers almost projections. So in other words, I would say somewhat fuzzy projections. Projections correspond to subspaces in an infinite dimensional space. Almost projections is, well, you could think about the same subspace, but with, not so closely defined, with some fuzziness around it. So Matt's thesis obtained new results, and which extend some classical results. And I think the importance of this is twofold. On the one hand, these extensions are new results, which are very interesting in their own right, opening new horizons. And on the other hand, they also allow us to better understand the classical results. For example, one of the interesting classical results was that certain measure of how two subspaces in Hilbert space differ is necessarily an integer number. Matt's result actually explains what one needs from this subspaces. So what is really behind these classical results? What makes them hold? So I think it's a very valuable contribution. It opened new horizons, and it also helps us to understand better some of the classical and well-known results. Okay, so here I think you can see some pictures of distractions of Matt climbing various tall vertical objects. I think I will leave it at that. And future plans, well, let me just read this. House husband, teaching computers to learn, teaching his cats more tricks, climbing at a crag near you, all of the above. Well, let me just say that whatever it is, I just want to wish you that whatever you do next brings you fulfillment and happiness. And it's been a great pleasure to have you as a student for these few years, and I'll miss you. So, Matt, congratulations on completing your PhD. It's a great achievement. I think I can say we are all proud of you. And as a grand celebration, let me pass on to, at least virtually, well, the PhD hood. Well, it's not Colorado colors, but at least it's scarlet and gray colors of your native state of Ohio. So congratulations, Matt.
Thank you, Shaka.
Well,
the pleasure was all mine working with you, truly.
Well, again, not hopefully not all the pleasure, but a big portion of it is mine. I think I enjoyed it very much. I think you did great, and congratulations.
Thank you so much.
I'd like to welcome the spring 2021 graduates and their families to the Math Department celebration. It's been a year, a small decade of a year, but it looks like you've picked a great time to go out into the world and make your mark. When the pandemic started, I was extremely concerned that for our students, studying virtually seemed like a highly low probability learning environment. But I have been extremely impressed with the resilience and flexibility that our students have displayed in overcoming these obstacles. That's not to say it was easy or even sustainable, but I'm relieved to have seen that it has indeed been possible. We've been living largely virtual lives, virtual classes, virtual meetings, virtual coffee, and now a virtual ceremony. As soon as the ceremony finishes, after all, we get to enjoy a virtual buffet. Fortunately, many of the things we believe you learn in the math department are less dependent on how you encounter them. Sitting or standing with a notebook thinking about hard problems does not require a specific setting. I therefore have full confidence in your abilities as budding mathematicians. While not all of you may end up in mathematical careers, I know you'll retain the ability to think deeply about hard problems, As you know, many problems do not get cracked with a mere 5 minutes of thought, let alone a month or even a decade. For example, the Fermat's last theorem took a long time. And you also have learned that there are unsolvable problems, even in mathematics, and it's nevertheless useful to be able to think about them. You, in fact, benefit from thinking and solving interesting results along the way. While the math you encountered here was at times difficult, some of you may remember, for example, the Calc 2 third midterm, you will find, if you did not already know, that in real life is even messier and has even more intractable problems. I hope you delight in the challenges that await you as you go forward. And with that, I'd like to say congratulations, graduates.